Right, there's all my work at the beginning. Let's go through this step by step here. It gives us a function, and it says find the average rate of change. Average rate of change is your slope formula, f of b minus f of a over b minus a. So we're going to go f of pi minus f of 0 over pi minus 0. So you've got to take the pi, plug it in for the x, and take the 0, plug it in for the x, and then go pi minus 0 on the bottom. So we're going to go there. I did that right there. I plugged the stuff in place for the x. You can see my work there. And then cosine of pi is a -1. Cosine of 0 is a +1. And then you just get this negative e to the pi carried down. Cosine of 0 is 1. E to the 0 is also 1. And then the pi carries down right there. So that's it for the average rate of change for part A. And then we know part B says the slope of the tangent line. That's just what's the derivative. We're going to find the first derivative and then plug in the pi over 2. So that's a product rule right there. So I'm going to go first function times by the derivative. The second derivative cosine has a negative sign plus the second function times the derivative of the first derivative. E to the x is e to the x. And I did a GCF, factor out e to the x, factor out also a negative. And then it left me with that. And then all we got to do is plug in the 3 pi over 2. Remember, you have 3 pi over 2, you're right here. So the cosine is going to be your x value, which is 0. The sine is going to be your y value, which is -1. So since you get a negative times negative, that makes it a positive e to the 3 pi over 2. So it's just basic slope formula, basic first derivative. You guys are good at that. Plug it in, get your quadrant angles there. So do your x's and the y's and get that down right. Where you got to do the most work on this one is letter C. It says find an absolute min and you got a closed interval. So when you see absolute, max, or min, you got that closed interval. It's a 3.1 absolute extreme problem. So what we're about to do, we're about to make an XY chart, and we got to check the endpoints of our interval, which they gave us 0 and 2 pi, and then we got to find any critical numbers. The critical numbers is where that first derivative is equal to 0. Luckily, we already found the first derivative right here. So I just set that first derivative equal to 0. Now remember, your e to the x graph is never equal to 0, all right? Because remember, your e to the x graph will just kind of like do something like that and never cross the x-axis right there. So you don't have to worry about that. But here, when you set this portion equal to 0, when you move that over, that's what you're asking, where is your sine equal to your cosine? And if you divide both sides by the cosine, you'll get tangent is equal to 1. And then remember, your tangent is positive, that's in quadrants 1 and 3. So it's going to be the pi over 4 and the 5 pi over 4, where your sine and cosine are like either both positives or both negatives, like that square root of 2 over 2 number. All right, so then those are your critical numbers where your first derivative is 0. So those also must be checked on your chart. They always have on that rubric, are you checking all of your candidates for the max and mins? And then you got to take these now and you got to plug them into the original function. That was the original function that up top. So if we plug in 0, e to the 0 is 1, cosine of 0 is 1. If we plug in the 2 pi, you're going to get e to the 2 pi, cosine of 2 pi is 1, so you get e to the 2 pi. When you plug in power 4, you get e to the power 4 times the cosine of power 4, which is radical 2 over 2. When you plug in the 5 power 4, your cosine of 5 power 4 is a negative radical 2 over 2. And see how I didn't have a calculator on this one, but they made it work out to where I can tell, since this is the only negative answer, that's going to be my absolute min. So there's your, then you're done right there. So just make sure we're practicing those. We've seen enough of those where I know we got to do a little bit of work on that. But if we're studying all that stuff there, that could be something that kind of separates us from the rest of the nation who doesn't want to do that. You know, we could put in some work and get that right. All right, and then either 2017 or 2018 was the year like they added like L'Hopital's rule. They used to be just a BC topic, but now it's an AB topic as well. So here's the deal, like, so you're gonna have the limit as x approaches pi over 2, right? And then you got, where am I looking here? So you got the limit as x of f over g. Now when you plug in pi over 2 right here, we get e to the pi over 2 times the cosine of pi over 2. Oh, I got that written down right here. E to the power 2 cosine of power 2. The cosine of power 2 is 0. So you get 0 times a number. You get 0 on the top. And then it's telling us g of power 2 is equal to 0. So when I plug in power 2 to the g function on the bottom, I also get 0 on the bottom. Now, a little technicality, don't write this down and then put equals 0 over 0. When I was at the AP conference, the chief grader was pretty adamant that he didn't like to see equals 0 over 0. You got to make sure you include that limit notation. So if you're going to write the 0 over 0, just write that off like way off to the side or whatever. Always make sure you keep your limit notation intact right here. Don't just put it equals f prime over g prime, like the limits are equal to each other, not just a fraction of the original functions is not equal to the fraction of the derivatives. You gotta make sure you keep that limit notation in there. So they were pretty stressing about that, you know, they were taking off like I thought that was a little bit too picky, you know, taking out points and stuff there if you didn't have that limit notation. But, you know, that's what we kind of have you practice that earlier in the year. So that you have to start with this. When you plug it in, you got 0/0. So I just kind of did that off to the side, which means I can do L'Hopital's rule. Basic stuff. They're just the derivative of the top, the derivative of the bottom. And then your derivative is right here for f prime. And so when you plug in power 2, you got to plug in power 2 for all those x's. So that's what I'm doing right there. And then limit as x approaches power 2 of the g of x, you're plugging in power 2 to the g of x, the g prime equation. This is the graph of g prime. So if I want to know g prime of power 2, this is g prime graph. So that just means when x equals power 2, what is that y value, which is equal to 2. So that's how I got the 2 on the bottom. And on the top there, the sine of power 2 is 1, cosine of power 2 is 0. So that was just carry that down. And then we're done. Crab Rangoon.